Okay, shall we continue? We are on problem number 28. This is another a difference of squares. The first terms are identical, the second terms are identical, and the signs are opposite. So with the pattern, this becomes my first term squared minus my second term squared, which gives me 64x squared minus 9. But again, if I don't remember that, no biggie. 8x plus 3 times 8x minus 3. Okay. 8x times 8x is 64x squared. 8x times negative 3 is negative 24x. 3 times 8x is a positive 24x. 3 times negative 3 is negative 9. Those cancel, and I'm left with 64x squared minus 9. Okay. All right. Once again, the key to success on this is remembering that this is x plus 6y times x plus 6y. If you use the pattern, this becomes the first term squared plus 2 times the first term times the second term plus the second term squared, which is x squared plus 12xy plus 36y squared. If you don't remember, don't worry about it. Okay. You can still use the area model, or you can use double distribution, however you want to do it. Noticing I'm just kind of mixing them up here. There's no rhyme or reason why I'm picking what I am. So x plus 6y times x plus 6y, x squared, 6xy, 6xy, 36y squared. When I add these together, I get 12xy. So my answer is still x squared plus 12xy plus 36y squared. Now we talked about this before. The main reason that you want to maybe learn the pattern is to go from here to here. Okay, if I have 5a minus 6 squared, remember that is 5a minus 6 times 5a minus 6. Using the pattern, I'm just going to do the pattern on this one just more than anything to save a little time. So this becomes 5a to the second minus 2 times 5a times 6 plus 6 squared, which gives me 25a squared minus 60a plus 36. Okay, 31 through 34 are all about dividing polynomials, and we're going to use the rule that this is really a shortcut for writing 30x to the fifth over 3x minus 18x to the fourth over 3x plus 42x to the third over 3x minus 6x to the second over 3x. And then these are individual monomials that I can deal with. 30 divided by 3 gives me 10. X to the fifth over x to the first. I subtract those exponents to get x to the fourth. 18 divided by 3 is 6. 4 minus 1 is x to the third. 42 divided by 3 is 14. Whoops, I forgot the 1. 3 minus 1 gives me x to the second. 6 divided by 3 is 2. 2 minus 1 is just x to the first. Okay, if I'm dividing this entire polynomial by 2m to the second. That's the same thing as dividing each of these terms by 2m to the second. Okay, so 14 divided by 2 is 7. 8 minus 2 gives me m to the sixth. 6 divided by 2 is 3. 5 minus 2 is m to the third. 22 divided by 2 is 11. M to the first. And anything divided by itself is 1. So it's kind of like when you're just whatever, how many terms you start with, that's how many terms you end up with. Okay, so if you're dealing with more than one variable, the process is identical. You just have to just a little more careful. A to the second, b to the second divided by ab plus 11, a to the second b divided by ab minus 7 ab to the second divided by ab plus 3ab divided by ab. Okay, so you have 5. The a's, 2 minus 1 gives me 1a. The b's, 2 minus 1 gives me a single b. 11, a to the second over a is just a. Anything divided by itself becomes 1. Okay, so the a's cancel. 2 minus 1 gives me just a single b. The a's cancel and the b's cancel. So I have a 3. Okay, so I'm taking 1, 2, 3 terms here and dividing them all by negative 5c. So I'm going to, since these are so little, negative 15 c to the third d to the second divided by negative 5c plus 40 c to the second d to the second divided by negative 5c plus 35 cd to the second divided by negative 5c. Okay, 15 divided by negative 5 is 3. The c's, 3 minus 1 gives me c to the second, and the d to the second remains the same. 40 divided by negative 5 is negative 8. C to the second over c is c, and the d to the second remains. 35 divided by 5 is negative 7. The c's cancel, and I'm left with d to the second. Okay, so let's see what we got here. 34 through 53. So there are a bunch of factoring problems. So clearly we've spent a lot of time on this. It was, half of the lesson, so so it's gonna be quite heavily on the test. And it's a skill that you're gonna need for all your future math courses. Okay, so I want you to remember your strategy. The first thing you do is look for a greatest common factor. Then you look at the number of terms, and that will tell you how you're going to factor it. And then you're going to check each of your factors and make sure you haven't missed something. And you can always check by multiplying. Okay, so if I start out here, I'm going to do my GCF first. And there is one. So the greatest common factor of 40 and 12 is 4. My lowest exponent is a to the third. So I'm going to write my GCF outside. Since I started with 2 terms, I will end with 2 terms. And I am dividing each of these by 4a to the third, so that gives me 10a to the second minus 3. Okay, so once I've got the GCF, then I look at what's in here. Okay, so there are two terms. There's no greatest common factor. I've always done that. So is this a difference of squares? The answer is no. So I'm done. That is my answer. I am done. I've done the GCF. Two terms told me to look for a difference of squares. It wasn't any. So that's it. Okay. All right, on 36, the first thing I want to look for is a greatest common factor. Well, I know I'm going to have to pull out a negative sign. So I know it's going to be negative. My leading term is negative, so I want to factor out that negative sign. There's no number in common to all of them except 1. But my exponents, I have a 5, a 4, and a 2. The smallest exponent is 2, which means my greatest common factor is negative x to the second. So I'm going to write this as negative x to the second. I'm going to have 3 terms remaining. So if I divide each of these by negative x to the second, I get 4x to the third minus 7x to the second plus 1. Anything divided by itself is 1. Okay, so now it's 3 terms in here. There's nothing I can do with this. I don't know how to factor an x to the third. So the remaining trinomial is not quadratic, so cannot factor. So once again, I am done. Okay, so on 37, again, I'm always going to look for a GCF. Well, this one has a common binomial factor. So I'm going to write this as m plus 1 times, and when I do that, I've got 2 terms left. When I get rid of that, I'm left with 7m, and that's a minus 8. This is not a difference of squares, so I'm done. There's my answer. Okay, on 38, I do have a GCF. It's a binomial. It's 2a, minus 5. Sorry about that. And I want to remember there's actually a 1 there. So when I factor out my 2a minus 5, I'm left with 3a minus 1. And I'm done. Okay, so on 39, I want to see if there's a greatest common factor. Well, they don't all have x's. And let's see. Yeah, there's nothing that divides all of them because 2 and 5 are prime. So there's none. But I looked. Okay, this is 4 terms. So I'm going to factor by grouping. Okay, so that means I'm going to write this as 2x to the third minus 14x to the second plus 5x minus 35. Okay, I've got my two groups. I'm going to look at each of these groups independently. Okay, so here my GCF is a 2 and my lowest exponent is 2, so this is 2x to the second. And when I divide by that, I get x minus 7. My GCF here is 5, and when I divide by 5, I get x minus 7. So now I have a common binomial factor. So I'm going to factor that out. And when I get rid of that, I'm left with 2x to the second plus 5. Now, I also want to look and see if I factored completely. On this one, since I have 2x squared plus 5, the only possibility would be a difference of squares, and that's not possible. Okay. All right, on number 40, let's see. 4 terms, so I'm going to look for a GCF first. They don't all have y's. And this one throws it. They're not all even, so there is none. So there are 4 terms. So I'm going to do some grouping. So this will be 18y to the third plus 12y to the second. And remember, I have to write that as a plus. So the negative sign goes with the 15. Okay, so my greatest common factor here is 6 and y to the second. So I have 6 y to the second. 18 divided by 6 is 3. Y to the third over y to the second is y. Plus 12 divided by 6 is 2. Y squared over y squared cancels. Now I want to remember to factor out the negative sign. So this is minus, and the greatest common factor here is 5. So when I'm dividing by a negative, that changes the signs. So this is 3y plus 2. Okay, so I have a common binomial factor now of 3y plus 2. And when I get rid of that, I'm left with 6y to the second minus 5. This is not a difference of squares, so I have done all I can. Okay, let's take a break on this.